Section 8.3, show that a quadrilateral is a parallelogram. Say that 4 times fast. First, let's start off with some theorems. Theorem 8.7, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if AB is congruent to CD and BC is congruent to AD, then this is a parallelogram. Theorem 8.8 deals with the angles. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if angle A and angle C are congruent, and angle B and angle D are congruent, then it's a parallelogram. Let's try one. An amusement park ride has a moving platform attached to 4 swinging arms. The platform swings back and forth higher and higher until it goes over the top and around in a circular motion. In the diagram below, AD and BC represent 2 of the swinging arms, and DC is parallel to the ground, line L. Explain why the moving platform AB is always parallel to the ground. So this is one of those word problems where you have to write a few sentences to get the explanation. So we know that AD and BC represent 2 of the swinging arms, and they're congruent because they're both 16 feet. So those are congruent, and AB and DC are also congruent. So we learned that when opposite sides are congruent, then it's a parallelogram. And you know that parallelograms, get the pen back out, it says here that AB, sorry, I just got interrupted. I think I was saying that AB is always parallel to the ground. And since it's a parallelogram, if AB is parallel to the ground, then you know DC is parallel to the ground. I'm sorry, it says DC is parallel to the ground. And because it's a parallelogram, if, excuse me, DC is parallel to the ground, then AB is parallel to the ground. Phew. Okay, you try. In quadrilateral, W, X, Y, Z, the measure of angle W is 42, the measure of angle X is 138, the measure of angle Y is 42, find the measure of angle Z. Is it a parallelogram? Explain your reasoning. If you need to draw a picture really quick, it's not a difficult problem, but if you could please push pause and try this on your own. Here you go. I drew a picture. I didn't know what the measure of angle Z was. I can assume, but we don't know if it's a parallelogram, so I cannot say that angle Z is 138 because it's equal to angle X. I first have to prove it's a parallelogram, then, or I first have to prove that angle Z is equal to angle X, then I can say it's a parallelogram. So when you get to these problems in the book, don't ask me what you need to do. Show your work showing that you can say it's a parallelogram, and then write down what theorem you're going to use. Okay? Sorry, interrupted again. So what I did, I know that the interior angles of a parallelogram have to equal 360. So I added 42 plus 138 plus 42 plus the missing angle and set it equal to 360, and then solved for angle A. So I know angle A is 138. And theorem 8.8, that's awful, sorry, theorem 8.8 says, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So I explained my reasoning. All right, moving on. Theorem 8.9. If one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. Excuse me. So if BC is parallel to AD and BC is congruent to AD, then it's a parallelogram. Theorem 8.10. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So I have diagonal BD and AC. They bisect each other because these are equal and those are equal. That's what bisect means. So it's a parallelogram. Let's try an example. The doorway shown is part of a building in England. Over time, the building has leaned sideways. Explain how you know that SV is equal to TU. Okay, we know that ST is congruent to VU because they're marked. And we also know that ST is parallel to VU. So, theorem, I'm just going to name it. Explaining my reasoning is stating those two facts and also saying I'm going to use theorem 8-9. It is a parallelogram. Okay, that's my explanation. I stated the knowns that are used in theorem 8-9 and I'm using theorem 8-9. So what value of x is quadrilateral CDEF a parallelogram? So it says that if your diagonals bisect each other, then it's a parallelogram. So we already know that CN is congruent to NE because it's marked. So let's set FN congruent to ND and solve for x. Because if those two are congruent, then we know that it bisected. And interrupted again. Where was I? I'm really sorry, guys. I'm here with my 6-year-old today, and he's interrupting me every 5 minutes. All right, so if we know that FN is congruent to ND, then we know that it's a parallelogram because the bisectors, when the diagonals bisect each other, which means this piece is congruent to this piece, and that piece is congruent to that piece. It's a parallelogram. So let's solve for x. Subtract 3x from both sides. Add 8 to both sides. X equals 4. That's simple. Okay, you try. There's actually 4 slides of you tries. So here's number 1, push pause, put it in your notes. I want to see it in your notes. Draw the picture. All right, there's number 2. Next one, what theorem can you use to show that the quadrilateral is a parallelogram? Push pause, please, and put it in your notes. There you go. What theorem can you use to show that the quadrilateral is a parallelogram? On your own, in your notes, draw the picture. There you go, and I think we have one more. Okay, you try on your own. For what value of x is quadrilateral MNPQ a parallelogram? Explain your reasoning. Okay, explain your reasoning. For this one, I showed my work. I set the diagonal MP, which is bisected by QN. So I set 2x equal to 10x minus 3 and solved for x. So when x equals 2, those two pieces of diagonal are congruent because theorem 8-10 says diagonals bisect each other. So QN is bisected because it's marked that way. MP, when x equals 2, is also bisected. This right here is going to help you with your homework. I would copy it down in your notes, put it on your note card, something, because in your homework there's going to be a lot of questions that say, tell me why this is a parallelogram, tell me why this is a parallelogram, tell me why this is a parallelogram. So you're going to be able to go to this, this information and pick one. Okay, if you have a picture where all the angles are congruent, you can say theorem 8-8. Okay, just showing both pairs of opposite angles are congruent. This is your explain. If you're showing both pairs of opposite angles are congruent. If you're showing both pairs of opposite sides are parallel. That's your explain and your reasoning. Okay, so copy that down. It's very, very helpful, all in one place. All right, show that quadrilateral ABCD is a parallelogram. Yes, you're going to need some graph paper for this lesson. So you're showing that it's a parallelogram. How do we do that? You're going to need, for your homework, the midpoint formula, the distance formula, etc. So I'm just going to pick some points and show that two segments are congruent. So let's do AB and CD. So I need to know the distance of AB. And then we have the distance formula. So if you remember, it's x minus x, 2 minus the negative 3 squared, plus y minus y, 5 minus 3 squared. 2 minus negative 3 is 5 squared is 25. 5 minus 3 is 2, squared is 4. So I have the square root of 29. Oops. And just leave it square root of 29. You don't have to do anything else with it. Now let's look at the side. So we're checking out AB and CD. We're trying to make sure they are congruent. All right, x minus x. 5 minus 0 squared plus 2 minus 0 squared. I get 5 squared, which is 25, plus 2 squared, which is 4. So we can say AB is equal to CD. All right, now we're going to use the slope formula to show that AB is parallel to CD. We could do this two ways. We could also do the distance formula again to show AD is congruent to BC. But y'all don't like the distance formula, so let's go ahead and use the slope formula. So we're going to do the slope of AB. Remember, it's change in y. Change in y is 5 minus 3 over change in x. 2 minus a negative 3. Sorry, I should title this. Now we're doing slope. Let's do slope of CD. Change in y over change in x. So the slopes are the same. I have the slope of AB and the slope of DC. So AB is equal to CD, and the slope of AB is equal to the slope of CD. Sorry. So if these are congruent and parallel, I'm going to go back to that concept summary sheet and say theorem 8.9 is my reasoning. Okay, refer to the concept summary. Explain how other methods can be used to show that quadrilateral ABCD in example 4 is a parallelogram. Like I said, we could have done the distance formula on all 4 sides and shown that the opposite sides are congruent, which would have been theorem 8.7. We could have also done the slope formula on all of the opposite sides to show that the opposite sides are parallel. And that would have been theorem, oh, that's just the definition of parallelogram. Let's see, what else can we do? Pair of parallel and congruent sides. So we did congruent, we did parallel. Angles would have been harder, so we don't want to do that. We did theorem 8.9. Oh, we could have done diagonals. Find the midpoint of each diagonal. And if they're congruent, then theorem 8.10. You have a homework problem. Oops, 8.10. You have a homework problem that's going to make you do that. Cool. Daily homework quiz. Number 1. Number 2. Number 3. And number 4. Awesome.